incredible keynotes this morning, especially from Jeffrey Moore, who's told us that we've not yet crossed the chasm. But from the speaker, from Dr. Shilley from Sears Holdings, who told us that, gave us very much of a message that Hadoop really needs to fit within the infrastructure that you already have. Well, anyway, so this presentation is kind of on that same sort of message. And the fact is that arguably, well, of course, Hadoop is used both for operational use and for analytics. Arguably, probably the majority of use cases amongst early adopters have been pretty much for analytics. And so that brings up kind of an interesting situation because there's been a lot of, you look at all the IT vendors who have discovered Hadoop over the past year and a half. A lot of them like IBM, Oracle, Vertica, Teradata, they're all basically describing Hadoop as basically being part of your enterprise data warehouse or an extension of it or an extension of your analytics system. So it brings up an interesting question from the standpoint of data stewardship. Hadoop is a different platform, contains different kinds of data. From a data stewardship angle, do we treat it the same way? Now that's a pretty big topic, and we're necessarily not going to cover the waterfront in this talk per se. And as a matter of fact, I believe across the hall there's someone doing kind of another piece of this, which is looking at Hadoop and Dodd-Frank compliance. So I want to level set right now. We're not going to cover everything. What we are going to do is take a look at several points fairly quickly, and we're going to do a deep dive into data quality. Okay, more specifically, what are we going to talk about? Well, first we're going to set the stage, set the context, which is what challenges does Hadoop throw at you compared to traditional data warehousing when it comes to data stewardship. We'll just do a couple of general slides on that, just set the context. Then we'll take a brief look at a couple points here, and the only reason why I put them up there, two reasons. One is that we've gotten queries at Ovum on these topics about privacy and about data lifecycle. And you've heard about, in the last couple of presentations, how we're using Hadoop as this kind of like the new tape. Question is that necessarily going to work out for you as an enterprise? But where we're going to spend most of our time is on the last bullet, which is on data quality, where we just delivered some research. And we've posed some questions, and we're also putting up some answers. And we have some time, and I hope that we will have some time left at the end. We have a lot of material here, but that hopefully we'll be able to have a little bit of discussion and back and forth on this. So I think we're a small enough group here that hopefully we can have a little bit of an informal conversation. Anyway, okay, so what basically has changed and well, actually it's kind of like, you can, for data stewardship challenges, that second tagline you can throw in your own. What's old is new, what goes around comes around. It's basically a combination of the new and the very familiar. Excuse me. First thing I want to point out is, before we go any further, is I'm introducing a new technical term here. We're going back to undifferentiated goblobs of data. We're taking gobs of data that we traditionally treated as blobs, except that in Hadoop, we want to see more, not just that it's an image. We want to see who are the people in that image. If they're holding up, let's say, if you're a soft drink maker, if they're holding up your can of soda, are they smiling? And other sorts of stuff. So we're actually trying to kind of pierce this sort of black box of blobs, and we're putting a lot of this stuff in there, and it's all sorts of stuff. Another trend, and this is actually sort of a return, kind of in a way, to the days before SQL, where essentially access to data was programmatic. And SQL gave us a nice declarative language where, okay, we did need to know something about the physical database, but basically you just told the program you wanted to get this data, or I should say that's an HTTP command, but you wanted to do a create and input, update, delete. Basically, programmatic access never went away. It actually started to come back with multi-tiered architectures with Java, where we started to do data grids. It's come back with a vengeance, with Hadoop. Even though you are also starting to see some interesting innovation, basically tying in SQL to access to Hadoop, especially with some of the new initiatives around SQL-H that Teradata is talking about. Anyway, in terms of storage, chances are you're using HDFS if you're using Hadoop. You may also be using HBase, so you may have some tables, but file systems are very much back in the center of what you're dealing with. It's kind of like going back and dealing with an operating system. Batch, of course, you've heard a lot about we want to get Hadoop to become more real-time, and basically it will happen. But the fact of life is that if you are doing large runs with Hadoop, it's going to be a lot of batch. The data has both changed and in some cases remained the same. In the case of Sears, for instance, they're putting a lot of structured data in Hadoop. But we're also putting a lot of everything else in there as well. And so you've got incredible volumes that basically would have blown the top off of SQL databases before this, variety of course. In some cases, velocity. We're talking about streaming events, and anybody who's a veteran of complex event processing and event streaming knows this is not a new situation, but where we're basically accumulating data at such speed in some instances is a game changer. And of course, then there's the question of the value of data. And you can take that from several different slices. One is basically, overall, why are we collecting this data? We're collecting it because it theoretically should have some value, but what's the value of different types of data? And that varies. So that's basically kind of a major change with Hadoop compared to, let's say, more traditional databases where basically things are more level and uniform. Which brings up the question, just because you can store all this data, should you? Okay. Anyway, more specifically, what are the questions we're going to be dealing with over the next half hour? Well, the first part is that can we and should we control all this data? Or should we just take all this stuff in? I mean, a very common pattern has been take this stuff in, and it's the whole idea with data science. You don't necessarily know what's in there, and you're doing this iterative sort of exploration to let it frame your problem. Very different from data warehousing. Then the question is, are there limits to how much we should know as an organization? That brings up sort of a privacy issue. We'll spend a couple slides on that later on, just to kind of review some questions briefly. As I was mentioned before, can we afford to keep just piling up data forever? And that's a life cycle issue. And then the last couple points are to deal with quality, which is when you're dealing with such, such magnitudes of data. Can we, is it practical to cleanse it? Should we cleanse it? Do we still need good data? Because maybe we need to keep the actual record of history. And if that history is a piece of bad data, well, that's part of the history. We'll get into that and hold that thought. Okay, at this point, I'm going to start to wipe some egg off my face. Because when I put this thing together, I forgot I was working with a new internal template, which has this header use of repeated table of contents page. What that means is we're going on the next topic, which in this case is privacy. Exactly. And we will institute that. I'll take that down that IBM has requested, or basically has recommended to us that we do that. But anyway, a couple points in this slide. Which is that privacy is not a new issue. But the fact is that we get more data than ever before, and it's coming from more sources, which basically brings this issue right to the fore. But anyway, it's not a new issue. We actually had that concern during Web 1.0 when we started putting up cookies, so we started to know where people were going. And now basically with a lot of the frameworks, such as the Java framework, we're able to start doing transactional processing on scale on the web, so e-commerce. So we started to know a lot more stuff about what people are doing, what they're buying, and so you might remember what Scott McNeil, that old sage Scott McNeil, said, which is essentially, you don't have privacy, so just get over it. On the other side of the screen there, I'm just making just taking sort of a couple of, just at random, picked a couple events with Facebook, which basically illustrates that this is really, privacy is really all a cat and mouse game. These companies do something, they get caught, they say that, and they say they'll perform, they'll do better, they'll behave better. And in this case, Facebook agrees to 20 years of federal privacy audits, and then they go off and do something else that kind of makes us sort of wonder. Anyway, this chart, just a couple points, which is one, privacy is a big issue, and I just took a partial screen scrape from a Wall Street Journal page, part of the series of what they know. They now run that as a regular, regular feature. This is just a screen scrape off that page. But the other side of this, I wanted to cite because basically after I presented Hadoop World, I had a client come up to me and ask me if I could do a workshop for them on privacy. And after I protested, like, what do I know about this stuff? This is a Japanese investment bank in Japan. They have some fairly strict laws on the topic. And so I did some fairly quick research. And I found an excellent source on the topic, a book by Terrence Craig and Mary Ludloff. They're from a company called Pattern Builders, which is a big data analytics firm. And it was roughly about 100, it's a little less than 100 pages, but they gave basically a very detailed account of, like, here are all the instances where essentially you don't have privacy. And this one, which was kind of the paraphrase up there, to me was the kicker, which is it all predates the internet. The point when your State Department of Motor Vehicles starts selling off your driver's license data or your car registration data, or when credit card companies or credit bureaus start selling off your data, you lost any sense of privacy. You were out there. So anyway, so as a company that is now putting together, that's now implementing Hadoop, you're learning more about your customers, so what do? And sort of to paraphrase Google, don't be creepy. On the right, I give sort of an example, which has actually become pretty viral about Target, which, like retailers, I mean, like Sears before, does lots of demographic slicing and dicing of its customer base, finds out what they're buying, so to get an idea as to what type of promotions they should aim at them. And in this case, they were looking at young women who are becoming pregnant because they sell lots of maternity products. And with that program, it evidently was pretty, turned out to be pretty accurate. They sent flyers out, to people they suspected were pregnant, and which promoted maternity products. It was based on basically a market basket of roughly about 24 products, which shows a propensity for pregnancy. And so this irate father comes storming into the store and basically, says, "What are you trying to do?" And he was talking about his daughter, who was a high school student, still in high school at the time. He was trying to encourage her to get pregnant. Turns out, this is sort of an updating of the old Teradata beer and diapers, I guess, sort of a myth. Turns out that she hadn't gotten around to telling him. Anyway, the lesson the takeaway for Target in that case was basically this really validated their whole analytics effort. But they need to be a little more sensitive about this and keep the communications, as I'm talking on the left side there, keep it in context, which they started sending out promotional flyers because their customers were not necessarily telling Target, "I'm pregnant." They were just buying stuff. So they sent out flyers, and instead of making it all maternity products, they would bury a few strategically placed products with items like lawn tractors. So it was kind of funny. But the lesson of the story is basically that this is a governance problem, not really a technology problem. Because you can get that data. It's not a question of whether you can. It's out there, waiting to be harvested. You need to keep the dialogue with your customers in context. You don't want to slip them any surprises. And the law is still trying to catch up. Okay, next table of contents slide. We're going to talk briefly about data lifecycle. And that came up several times this morning. Yahoo talking about they have, I think it was, 40,000 nodes, world's largest Hadoop cluster. Well, they invented this stuff, so. But, and the thing is that for most enterprises, we've really not hit the limits yet. But what I really would suggest here, and of course all this is because Hadoop was really designed for such extreme linear scale out. My take on this, and this is something which we're actually going to be looking at more closely in coming months, but we've gotten some questions on this, which is that my take is that really at this point, it's really management and skills that are going to be the practical limit. I mean, you can automate a lot of this stuff, but the more data you have, the more complex your challenges for managing all this stuff. And so, as I said, this is just a preliminary take on this. Come back in a few months and give me your card, and we'll talk some more about it. Anyway, so let's now cut to the chase, which is data quality, where we just delivered some research here. This is where I would really, if we have some time, would love to get some discussion on and some feedback on this. But anyway, and this is sort of a restatement of the questions that they were posing up front, which is, can we cleanse terabytes of data that we're taking in every day in some cases? Do we still need good data? Conventional data warehousing practices, basically put a huge emphasis on data quality. But the other end of this is that, are there some new approaches that could be applicable to I don't necessarily want to use the term cleansing big data, but managing quality in big data. Okay, let's frame the issue first, which is that data quality, of course, is not necessarily a new issue. And if I'm guilty of one thing, I take a look at a story. I was a history major in college, so I say, hey, all this stuff has happened before. And the fact is, garbage in, garbage out is a phrase that dates from the dawn of computing. Data warehousing, though, kind of brought that to the forefront because arguably, if you have a single system, single application with a single purpose for data, you have some explicit and implicit knowledge about that data. So if there are problems, you could probably do some workarounds. When data warehouses basically started to come onto the scene, it meant that we were starting to widen out our sources of data. We're taking in data from longer time periods, so that maybe we're taking data from times when we weren't quite as vigilant in filling out all those fields, or we have different naming conventions or what have you. And the fact was that the way, the types of, doing analytics on structured data, the key here was basically is that you need really to make apples-to-apples comparisons. And so data cleansing became a pretty significant issue as data warehousing started to enter that sort of, as it started to cross, to quote Jeffrey Moore, to cross the chasm. And so we evolved a number of approaches, a number of automated tools and practices, profiling data, so we can take a big look at this and get an idea as to the type of challenge we have in terms of making this data reasonably consistent. Tools for automating the cleansing, and for companies that really were to take a more architectural approach because of various business imperatives, whether it be regulatory driven or whether they're trying to get a better handle of their products. Now, a number of companies have started to implement master data management. The issue with Hadoop is, of course, just as data warehousing kind of expanded the challenge with data quality and had to make quality more of an explicit process, because you're dealing with a wider variety of data, Hadoop really blows that all out. And the thing is that you're not only dealing with more data, but in many cases, I mean, not all, because obviously with Sears, they're basically using Hadoop to basically offload a Teradata data warehouse. But in a lot of cases where you're collecting data from the wild, you're dealing with data that basically you may not have very much this very explicit or implicit knowledge about. And so your task regarding data quality became a lot less bounded, became a lot hazier. And so one thought is, okay, well, it's a more difficult problem, but why don't we kind of brute force the answer and throw MapReduce, put the same types of techniques that we applied with automated tools and run it into MapReduce. Consultant David Lawson put together a very good paper, and I put the link up there, and I'll be happy to share it with you afterwards. I do have the link in the slides, and I can share with you the slides. But we basically put together a very good paper on the capabilities of Hadoop and MapReduce, and one of these was basically looking at how well does it do various data quality operations. I won't read through each of these bullets, but the takeaway is that you can't simply automate what you already have done using MapReduce. There are a lot of things that either you can't do or you have to make sure you do, but it's not necessarily a slam dunk to say just run it as a big map and as a big reduce. Okay, so that brings us to the question of, should we worry about this? Do we need high-quality data? Because there's a lot of, just as Jeffrey Morris described a lot of these, financial systems that we put together, these transactional systems, as a system of record for the enterprise. In a sense, if you're collecting events from the outside world, Hadoop kind of becomes your system of record for the outside world. And maybe some of that data is corrupted, but isn't that part of the historical record? Well, there is certainly a rationale that says don't cleanse this data, or if you're going to do anything with it, keep the original version of it intact. But the question then is, and we'll get into that in another chart, but so the question is basically, should we cleanse this data, or should we apply some sort of quality management? From our research, we basically see that basically it's a matter of looking at the nature of your application and the nature of the data. The nature of the application will give you an idea in terms of whether you should do this. The nature of the data will tell you whether you can do this. But this is it's not like any one check mark is going to say yay or nay. And a good example of this is, how mission critical is your application? Conventional wisdom would be to say, well, the more mission critical the application, the more important it is to cleanse the data. And I'll give some examples on the next page which show that basically there may be some applications, especially dealing with a lot of online operations, that are really meant to give more the big picture rather than an exact picture. That may be mission critical to your business. When Yahoo serves up a web page, that's mission critical. They need to serve that up and serve up a page that's going to be responsive to you. But it's not an exact science. And if there's some data there that may not, that may be a little erratic, it's not necessarily going to kill that application. On the other hand, obviously, a financial application is a very different story. So anyway, it's just that the degree of mission criticality puts a context on this. It doesn't necessarily place an absolute answer. What does place an answer is regulatory compliance. But again, that doesn't necessarily mean you need to cleanse 100% of your data. You just basically need to vouch for how you've made your decision-making process. You need to preserve some audit trails for that process. So this is the data that we're certain of. We made a decision based on these criteria, but then we widen this out and we use this for context. It doesn't necessarily mean that you cleanse everything. It does mean that you document what you do. And of course, implicit in all this is what's the degree of business impact, because basically the application is a matter of kind of icing on the cake. Probably not as critical to really go through and look at that data as much as just get sort of a big picture. Anyway, in terms of the data, that's going to determine whether and how you cleanse this data. And the thing is, with volumes, as I've been sort of implying before, traditional methods, which tend to be record by record, even if they were automated, are just not going to be feasible when you're dealing with much larger magnitudes of data. Variety itself has a lot of different impacts, because there's some types of quote-unquote unstructured data, which is really variably structured data. There's some forms of that data that you can cleanse. And text, basically human-readable text is a great example. Text analytics is a very established practice. On the other hand, log data, even if you wanted to cleanse it, which you don't, the formats vary all over the place, and you also don't know whether the source is reliable or not. But anyway, velocity. If you look at any veteran that's been involved with complex event processing applications, basically you didn't cleanse data. You were using this to make operational decisions. Putting a cleansing step basically introduces latency that defeats the purpose. Now, if you then decide to strip off some of that data and then persist it, then it's another story. But again, at that point, the velocity is slowed down. And in terms of value, and I've mentioned this kind of off and on through this presentation, there's value of data in aggregate, and there's value of individual record, which could also be related to information density. So for instance, a name of a person, that's going to have high density versus, as I said, a log file or a media file, which is in and of itself may have very little value or density. Okay, so some examples. I've been sort of obliquely referring to this. Apply this criteria. Web ad placement optimization. You sort of saw that, in the Yahoo presentations before. This is definitely a mission-critical application. Yahoo could not run its business if it wasn't somehow able to optimize the experience of its members, going to Yahoo and going to the landing page and getting a page that's tailored to the needs and ads that basically are applicable for the audience. But on the other hand, you're dealing with data which basically is highly variable. And the fact is that this is really a probabilistic application. So it's not going to be 100% certain. And so therefore, there is margin of error that is tolerable here. So therefore, a conventional data cleansing process is probably not a great idea. On the other hand, counterparty risk management for financial markets, very regulated and becoming even more so. The trick here, though, however, is that in many cases, traditionally Wall Street firms took in fairly uniform data, stock ticks or whatever, but they're now starting to widen this out to other sources, which they don't necessarily have control over or have exactly a lot of explicit knowledge. For instance, let's say environmental factors. For instance, let's say I may be tracking the risk of basically a counterparty to take up an issue regarding, let's say, which might involve some form of seasonal retail, and all of a sudden we find out that the weather has gone out of whack and the retailer has the wrong product in place, and so therefore maybe that derivative and that counterparty's ability to satisfy their obligation might not be so solid. But that's a case of where, again, you're going to have data which has varying quality, and the important thing here is you need to vouch for what you have, but not necessarily cleanse 100% of it. Customer sentiment analysis is very similar to the web ad placement example. Managing smart utility grids or urban infrastructure, that's very mission critical. The data itself is going to be, it's basically going to be sensory data, which as a practical matter will not be feasible to cleanse in the conventional sense. Having said that, though, and in the next slide we'll go into this, there are things you can do about sensory data which may be actually quite relevant. And actually this really leads to the whole question of, can bad data be good? Conventional data warehousing, as I said before, is traditionally an apples-to-apples type of comparison. That was the whole idea. You took relatively uniform sets of data, and you want to make sure that the data was consistent, so you could make reliable comparisons. Well, the question, and I've given a couple examples, sensory and human-readable data. And the key here is really trying to get a sense of, is this data wrong? Is it, is it an outlier? Is it just a weird outlier? Is it a freak? Or does it indicate some sort of drift which may have some further meaning and actually yield some pretty significant value? So, I mean, the questions that comes up is basically, you're starting to see this data drift. Does this mean is it time to recalibrate the devices, perform preventative maintenance, or is the environment changing in ways that you didn't expect? And like a good example of that is global weirding, where you're getting strange temperature swings that maybe in past years you would have thought, well, the instruments are kind of out of whack. Well, maybe it's becoming the new normal. You're measuring, let's say, water levels, on a river that's prone to flooding. So the question is that some of this data may seem to be off the mark, may actually be pointing you to a new revelation. And the similar principle applies with human readable data, where we might be dealing with things like identities or propensities. The fact that all of a sudden, I just traded a car and I just got a new car and I'm now doing I'm buying new things because of it, which were totally uncharacteristic of my behavior before this. And okay, we can explain that with my car purchase, but how does this affect what other types of things I buy in my day-to-day life, or does it change my my habits? For instance, all of a sudden I like this car and I want to drive more around the neighborhood. So again, it's the same principle as with sensory data. Are changes that otherwise might seem out of character becoming the new norm? So given all that, are there some new approaches emerging? And we would suggest that there are, and I'd love to get some discussion on this if we have some time. The top one is something which is actually already pretty much practiced, maybe not actively, but it's what we call crowdsourcing data. The idea is that as you diversify your data sources, the idea is to get as many different points of view as possible, and hopefully it's not like the old Kurosawa film. I don't know if anybody was a fan of old Kurosawa films. There was a film Rashomon where you had all these different observers that saw reality differently. Well, hopefully it's not it's the exact opposite, which is that the more points of view you get, or the more, let's say, data points that you get, that you can now start to triangulate and get a sense of a fix of what really happened. And the idea here is, there are a lot of different metaphors we can use, but the idea is that basically you overwhelm the bad data, overwhelm the noise with good data, because you basically just essentially crowdsource this. What would actually be, and I sort of go into this in more detail in the under data science here, is we can actually employ this strategy actively and start to do some comparative trend analysis on incoming streams to dynamically identify what is the norm and how this norm is shifting, but also start to direct our attention at the bad data as well. And that's what I kind of go into in the next part. We talk about data science, which basically, popular phrase which came up after 9/11, but which you hear even a lot when in the context of talking about what data scientists do. These are folks that are supposed to be, these are like supposed to be folks that are supposed to be smarter than Albert Einstein. And I won't bore you with all the description of all the things that they're supposed to do, and probably there's some of you in this room that aspire to be that if you're not that already. But the thing is, if there was like a single phrase that described what you do in your job, is to connect the dots. What I'm suggesting here is we can also apply the same techniques to correct the dots. And now, what I'm not suggesting here is that you should take these very highly paid and very hard to find people and turn them into QA specialists. What I am saying is the same techniques that they're using to discover data and to perform analytics, use those same techniques to start looking at the weird data. Because who knows what you're going to find. You might find that maybe this data is, it's garbage. Or you might find that basically there's a reason for this garbage and therefore there's something that you need to do about it, or it means something's changing that we didn't expect. And another approach that basically I spoke with, that in speaking with some folks, some consultants down on Wall Street, and they're using I hate to keep going back to counterparty risk management, it's just a great example. But they were actually taking more of an enterprise architectural approach, which in of itself is not big data specific, but the way they're using it is. In this case, they were building basically a fairly flexible semantic, or domain, a semantic model of a specific domain. And the idea of building a model is that this model can be flexible and change over time as things change, because financial markets rapidly change. But the idea is put a model to this and essentially judge the data that way. But with what was specific to as they started to widen out their sources beyond, let's say, stock market, between market feeds, they needed to somehow vouch for the data that was being used to make decisions. And so their whole idea was use this model to essentially apply whatever cleansing logic there was, not at the point of ingestion, or not at the point of basically where you're trying to just maintain the data, but do it on demand at runtime when the data is needed. So that made it's helped to chop the problem down to size. And again, that's very critical for regulatory-driven apps. So anyway, just in summary, Hadoop throws a number of curves, brings a number of major challenges to traditional practices for data stewardship with data warehousing. And it's a combination of old and new challenges. As I said with privacy before, and again, this is really a huge topic in of itself. We could run a whole conference on this and would barely scratch the surface. But just kind of a takeaway that we've gotten is basically don't be creepy and keep your conversations in context. The question is, are there limits to the data lifecycle? And the fact is that most organizations are not, right now the practical limit for Hadoop 1.0, the current Hadoop, 4,000 nodes. Most enterprises are not going to come anywhere near that. And in the next version of Hadoop, hopefully sometime next year, 2.0 is supposed to blow that out by at least a factor of 2x. So you're not going to technically exhaust Hadoop, but you may technically exhaust the skills and capabilities that you have to manage your data store. But again, let's let's keep in touch on this one, because basically, as I said, we are going to look at this topic a lot more closely in coming months. Finally, with data quality, it's a spectrum of choices. It's not a single answer, not a single silver bullet. Essentially, it's a spectrum which is going to be based on the nature of your application and the kind of data. And basically, those approaches can imply, can range from no, just keep the data as is, to doing various different, in some cases doing classic ETL if you're going to a conventional data warehouse, or basically to start doing some fairly data scientist-oriented, statistical approaches. Again, no single silver bullet. So with that, I think we have some time for questions here or any discussions. So does anybody have anything that they'd like to ask? And also, I would ask that if you have any questions, please come up to the microphone, because they are recording this.
I'm a consultant. I have clients coming to me now asking about integrating Hadoop into their archive, i.e., can we offload some of the costs and problems of dealing with tape? And I know she had a couple of points up there, but you kind of skipped over them. Could you elaborate and potentially talk about cost factors between the two?
Sure. And
the reasons for making the decision to go one direction or the other?
Right, yeah. Yeah, I didn't really get into this in depth, but, I basically have found, there are a lot, and actually we kind of saw that in the Sears presentation this morning. There's been a big question, is Hadoop the new tape? And the idea, and what drives this is not, I'm not an expert on the economics of tape media systems, versus Hadoop. What I do know is basically Hadoop is going to be a lot more accessible than tape, which you basically have to then mount this stuff on the drive and then read this back in Hadoop. That data is there, and if you have somebody who knows how to use Hadoop, that data is available. And the fact is that the way Hadoop has traditionally been set up, there's a whole other can of worms here. Basically, scale out commodity hardware, direct attached drives. So the idea is this is very cheap hardware. You can just keep adding this stuff as your data, as your data, expands. So from a physical standpoint, as I said, I don't know the comparative costs. From a physical standpoint, it's relatively inexpensive. But again, from an operational standpoint, I mean, part of it is there's an issue with, do we have enough Hadoop skills out there? And the technical skills are going to solve themselves, so that's a limitation. But the other part comes to a more generic challenge, which is the ability to manage large clusters. And now certain types of organizations, certain sectors have ample experience. You go to, let's say, a Wall Street house. They were setting up computing grids like, 8, 10 years ago. So they have that experience. Whereas, let's say, if you're a more, quote-unquote, normal enterprise, you may not have quite as much experience with that. On the other hand, this is another point, but of course there are a number of pros and cons on this. What about the cloud? Well, it depends on where this data is coming from. And so if you're trying to offload from internal systems, you have to then start, basically factoring in the cost and resource of moving data. Versus, and this is probably not what you're asking, versus if you're collecting data from the outside, then basically the cloud could be an option there. It might be cheaper. But again, in terms of basically basically going through and the reason why this is an issue is that at some point, when you start collecting all the data from the outside, which is not the traditional data you would think about with archiving, do you want to archive that? And as I said, Hadoop allows you to really scale out and contain a lot of that data. Is it economical? Do you have the resource to do it? As I said, stay tuned. Any other questions?
Hi. So my question is, how do you feel people should kind of balance privacy requirements with this giant data warehouse? Like if, for EU privacy rules, there is a requirement that when someone opts out, their data is gone. But you now have somebody's data inside of this giant, 20 gigabyte file. Mm-hmm. How do you remove 3 people from it?
Oh boy. As I said, this is a huge topic, and I have not done the research on that yet, so I can't give you a definitive answer. But basically, it's just kind of like an event stream. And so somebody opting in, opting out is an event. And so therefore, this basically suggests that probably there's some sort of streaming solution, maybe highly specialized, where you're looking at the opt-ins, opt-outs, and using that then to basically then start to trigger basically probably some batch runs accordingly to basically ferret out those records. Basically, the capability for that, the expertise for that really has not been developed. This is more a case of we're getting the ability to do this stuff, but we haven't figured out how to manage it. And the scenario you're talking about is an excellent case. Any other questions?
I have a quick question. You mentioned data privacy earlier.
I'm sorry, can you speak up?
About privacy?
Yeah.
What trends are you seeing that could potentially help the whole ecosystem get to a more, equitable solution here between government and social media? And there's, good business use cases. There's, it's going to be a thriving economy. At the same time, people want to manage their privacy. How do you see that work out?
Well, number one, I don't expect that government really is going to be part of the solution. I mean, and one is that it can't keep up. And just the question that was given, thrown at me, just before this, just so as an example of like, how do we, now that we provide a mechanism, how do we basically take advantage of it? I think what it really comes down to is business best practice, and the fact is you don't want to piss off your customers. And the thing is that, it's funny, like with Facebook, I'm up on Facebook. I probably don't use it very actively, but it's like, I'm not going to go up there and talk about every single contact I have, or go up on Foursquare and talk about every place I'm going, of course. That being said, I'm based in New York, and I'm going to a Hadoop users group meeting at Foursquare next week. But anyway, I think it's really a matter of what your customer base is really willing to put up with and what they expect from you. And the thing is, Facebook users, at least at this point, have a lower expectation of privacy, whereas basically target customers are dealing with a much broader sort of, you're dealing with the population as a whole, which will include Facebook users, but also include people that do not do social computing, and therefore don't expect to have such intrusions into their lives. That being said, though, you could have said the same thing 10 years ago with the emergence of e-commerce, for all, but I think to some extent, so I think you need to take a look at what are the preferences of your customer base, because at the end of the day, that's really what it's all about. And I don't really expect government or, let's say, industry bodies to really legislate this from the top down or whatever. It's really a matter of what makes sense to your business. Anything else? Well, I think our time has run out. In fact, I see a red light up there. So anyway, I very much thank you for coming out. If you have any questions, feel free to come up, and I'll be glad also to share my slides with you if you give me your business card. Thank you.